Let's see all the units and dimensional formula of chapter number 1. First one is electric charge. The basic formula for electric charge is Q is equal to IT. Unit of current is ampere. Unit of time is second. So unit becomes ampere into second. The ampere into second is also called coulomb. Its dimensional formula. Ampere means A1. Second means T1. So A1 T1 is the dimensional formula of electric charge. Sometimes electric charge is also taken as a base unit. So in that case, its dimensional formula can also be Q1. Let's see electric force. Electric force, the equation of electric force is F is equal to K Q1 Q2 by R square. As it is force, we can say its unit is Newton or dyne. This is its unit and dimensional formula. The dimensional formula of force is quite simple. It is M1 L1 T minus 2. Electric field. Electric field is defined as E is equal to force acting per unit positive charge kept in electric field. E is equal to F by Q. Let's see its unit. The unit of force. See, it is F by Q. Unit of force is Newton. The unit of charge is Coulomb. So Newton per Coulomb is unit of electric field. One more unit. We can say Newton per Coulomb. If I multiply it with meter and meter value doesn't change. So this becomes, this Newton into meter is called joule. This is joule. Newton meter is called joule. So we can say it is joule per Coulomb meter. This joule per Coulomb is called volt. So we can write it is volt per meter also. Let's see dimensional formula. F by Q is, we can write force is M1 L1 T minus 2 by charge is A1 T1. So this will become M1 L1 T minus 3 A minus 1. If charge is taken as a base unit, we can write again F by Q. If we are taking charge as base unit and not A1 T1, we can write it is M1 L1 T minus 2 by Q1. It becomes M1 L1 T minus 2 Q minus 1. So electric constant K. See, we know that F is equal to K Q1 Q2 by R square. This K is called electric constant, or we can say proportionality constant for Coulomb's law. So this K becomes, K is equal to FR square by Q1 Q2. So let's see its unit. The unit of force is Newton. The unit of force is Newton. So I will write Newton. R square means distance square. It becomes meter square. And this charge into charge becomes Coulomb into Coulomb becomes Coulomb square. So Newton meter square per Coulomb square is one of the unit of electric constant. We can also write it as, see, Newton meter square. We can write it is Newton meter into meter by Coulomb square. Value doesn't change. This Newton into meter is called joule. So we can write this is joule into meter per, this is Coulomb square. We can write Coulomb into Coulomb. This joule per Coulomb is called volt. We can write it is volt meter per Coulomb. So the units are Newton meter square per Coulomb square. We can say it is joule meter per Coulomb square or volt meter per Coulomb. All these are unit of electric constants. Now let's see its dimensional formula. See, K is FR square by Q1 Q2. FR square by Q1 Q2. The dimensional formula of force is M1 L1 T minus 2. R square becomes L2. Q1 Q2 charge into charge becomes Coulomb square, or we can write it is A1 T1 the whole square. So that will give M1 L3 T minus 4 A minus 2. So this is the dimensional formula of electric constant. If charge is taken as the base unit, we can also write, if charge is taken as the base unit, we can write it is M1 L3 T minus 2 Q minus 2. So this will be the dimensional formula if charge is taken as the base unit. M1 L3 T minus 2 Q minus 2. Now Let's see dielectric constant. So dielectric constant K is the ratio of permittivity per permittivity of vacuum or permittivity of free space. So K is equal to epsilon by epsilon 0. So obviously we can say it is unitless and dimensionless. Now let's see permittivity. This is very important. Let's see the equation from where we can have the unit of permittivity. F is equal to 1 by 4 pi epsilon 0. That is also called K. If it is vacuum, we can it is epsilon 0. So 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is the equation of force. Here epsilon 0 is called permittivity. If it is epsilon 0, then it is permittivity of vacuum. If it is just epsilon, it is permittivity of a given medium. So this epsilon 0 becomes 1 by 4 pi F Q1 Q2 by R square. Now let's see its unit. See, charge into charge becomes Coulomb square. We can this is its unit will be Coulomb square per force means Newton, R square means meter square. So Coulomb square per Newton meter square is a unit of permittivity. Now let's see, we can also have some different units derived from this one. Newton meter square, Coulomb square per Newton meter square is Coulomb square per Newton meter into meter. This Newton meter is called joule. So we can it is Coulomb square per joule meter. So if you are given options like which of the following are the units of permittivity or which of the following is not the unit of permittivity, you can be given three options, correct and one incorrect. So you have to figure out which is correct, which is incorrect. So Coulomb square per joule meter is also the unit of permittivity. This joule per coulomb is called, see, we can say it is Coulomb into coulomb by joule into meter. This joule per coulomb is called volt. We will write volt in denominator. So it will become coulomb per volt into meter. So these all are the units of permittivity. Now let's see its dimensional formula. See, this is Coulomb square per Newton meter square. Coulomb square means A1 T1 the whole square. A1 T1 the whole square by Newton means M1 L1 T minus 2. Meter square means L2. So this becomes M minus 1 L minus 3 T4 A2. Okay, now tell me in the comment section if this coulomb is taken as a base quantity, like charge is taken as a base quantity, what will be its dimensional formula? Write down in the comment section. So correct answer for it will be, see, this is Coulomb square means Q2 by Newton means M1 L1 T minus 2, meter square means L2. So this becomes M minus 1 L minus 3 T2 Q2. So this is the dimensional formula if charge is taken as the base quantity for permittivity. One more important physical quantity called electric flux. Electric flux. It is given by the formula phi is equal to E into A. One more formula is also according to Gauss law. We can say it is Q by epsilon 0, sigma Q by epsilon 0. For writing of the unit, we can take it is Q by epsilon 0 also. So its unit will be, see, electric field. Electric field is force acting per unit positive charge, and area is length into length. We can say it is L square. So the unit of electric flux will become, the unit of force is Newton. We can write it is Newton per charge is coulomb. Length square means meter square. So Newton meter square per coulomb is a unit of electric flux. We can also write it as Newton meter into meter by coulomb. Value doesn't change. This Newton into meter is called joule. We can say it is joule per coulomb into meter. This joule per coulomb is called volt. We can write also it as volt into meter. So these are the units of electric flux. We can write volt into meter, joule meter per coulomb, Newton meter square per coulomb. All these are the unit of electric flux. Now let's see its dimensional formula. So dimensional formula of electric flux. See phi. See joule. Joule is m1 L2 T minus 2. Meter is L1 and coulomb is A1 T1. So this becomes m1 L3 T minus 3, sorry, T minus 3 A minus 1. So this is the dimensional formula of electric flux. If charge is taken as a base unit, then it will become phi is equal to, if charge is taken as a base unit, here we write coulomb. So this will become m1 L3 T minus 2 by q1. This becomes m1 L3 T minus 2 q minus 1. Now let's see electric dipole moment. Integrated as p is equal to 2aq. It is a vector quantity. We can also write it is like this. P is equal to 2aq. Let's see its unit. 2a, actually it is a distance between two charges. If this is plus q charge, this is minus q charge, the distance between two charges is 2a. So 2a is a distance. So we can write this will be meter and this is charge. So we can write it is coulomb into meter. See, if a unit is made up of the first letter of scientist and meter, centimeter or something like that, we have to write the symbol of scientist's unit as before the meter. Like this is coulomb into, we cannot write like m into c. This will become millicoulomb. So we have to write coulomb into meter. Now let's see its dimensional formula. Coulomb is A1 T1, meter is L1. So dimensional formula of electric dipole moment will become m0 L1 T1 A1. So once again, if anywhere you see a unit like this, if it is nanocoulomb, we'll always write like nanocoulomb. This is nanocoulomb. Okay. If it is millicoulomb, we'll write it is millicoulomb. But if it is like this, C into M, this is called coulomb into meter. So these two things are not same. MC is a millicoulomb. This is coulomb into meter. Okay. So these all are the dimensional formulas of chapter number 1. Let's see in the next video the dimensional formulas and unit of chapter number 2.